last class we discussed a formal definition of big O notation. So when do we say that f of n is big O of n, big O of g of n? When do we say that f of n is big O of g of n? So if there exist two constants c and n naught such that f of n is less than or equal to c into g of n for all n greater than or equal to n naught. That's what we discussed now in the previous class. That's what. At here, C and N naught, are they unique?
Yes, sir.
C and N naught, are they unique? Or we have different options for C and N naught?
Different options.
We have actually infinite number of values for C and N naught. They are not at all unique. Not unique. Is that okay? Oh, again, to recall, say 7n cube minus 8n square plus 6n plus 20. Is it big O of n cube? Is that big O of n cube? Is that true?
Yes.
Is that true or not?
Yes, sir. True.
Yes. Now say someone has asked us to show that 7n cube minus 8n plus n plus 6n plus 20 equal to big O of n cube. How to show that? How to show that? So let us consider this as f of n. This is f
Left
of
hand
n.
side is f of n and
This is g of n. This is g of n. So somehow we need to show the n cube plus 6n plus 20 is less than or equal to some constant into n cube for all n greater than or equal some constant. Is that okay?
yes, sir.
Okay. Now tell me how to find constant here. How to find constant here? Is 1 correct? Is 1 correct? For example, n equal to 0 if we take, n equal to 0 we take, whether it satisfies the condition? That is, my question is, c equal to 1 and n naught equal to 0. You see, n means n naught is 0. Whether it satisfies or not. C equal to 1, n naught equal to 0.
Yes, sir.
Is that true or not?
Not satisfied because here the 20 is not less than or equal to 0.
Okay, so from this, if I substitute n not equal to 0 value, here we will get 20, because 7 into n cube everything is less than or equal to 1 into 0 cube, no? 1 into 0 cube, is this correct? Is this correct? Is that correct? No, the condition is not satisfied. That means this is not correct choice. What about c equal to 1 and n naught is 1? Is that correct? C equal to 1, n naught is also 1. C equal to 1, n naught is 1. Is that correct? C equal to 1, n naught equal to 1 if we take, n naught equal to 1 if we take, what happens here? 7 into 1 square minus 8 into 1 cube, 7 into 1 cube, 8 into 1 square plus 6 into 1 plus 20 is less than or equal to 1 into 1 cube. Is this correct? Is this correct?
No.
No.
No. Now c equal to 1 and n naught equal to 2. N naught equal to 2. N naught equal to
1 and not 2.
it satisfies or not? N naught equal to 2 means how much we get here? 7 into 2 cube minus 8 into 2 square plus 6 into 2 plus 20 is less than or equal to 1 into 2 cube. Is that correct? Is that correct?
No,
Is that correct?
No,
It's
no,
false.
false.
Okay,
false.
that is false. That is false. Now let us slightly increase this. C equal to 7 if I take and N not equal to 0. Why? Because here 7 and cubed is there. No, that's why I thought of taking C equal to 7. Is this correct? Is that correct?
720.
Is that correct?
20.
7
20
into 2, 7.
equal to 7. C equal to 7 and not equal to 0, madam.
C equal to 7 and N not equal to 0.
Yes. Correct, sir.
No, madam. This also fails. No. N not equal to 0 if I take 7 into
See
0
this side.
0 square plus 6 into 0 plus 20 less than or equal to 7 into 0 cube. No.
Okay.
Now, then we get out. Okay, I think here 20 is there. That's why I need to increase N naught value. So C equal to 7 and the N naught equal 4 if I take. 4 if I take, whether it works. C equals 7, N naught equal 4.
4 cube.
Yes. 20 is
N
less than
equal to
64.
4, madam. C equal
N equal to
7 into
4.
4 cube
Yes,
minus
7
8 into 4
4
square
cube.
plus 6 into 4 plus 20. It should be less than or equal to 7 into 4 cube. That means what? This entire value should be less than 0. No? Is that less than 0? Is that less than 0?
Not equal to 4. How is the less than or equal to 0?
Okay. Or simply
Okay,
whether is this true or not, you please check. That is enough. Okay.
No.
Easily we can show that that is true. No, it holds. No. Here 7 and cube same. Here 24, 6 fours 24 plus 20, 44. But here it is minus 128. No. This is true or not? Okay, I'll allow you. This is 7 into 4 cube, let it be. Minus 8 into 4 square, 16, 128 plus 24 plus 20. Is it less than or equal to 7 into 4 cube?
Yes, sir. Yes, sir.
Correct, no? If it is true for 4, whether it will be true for 5? If it is true for 4, whether it will be true for 5?
Yes, sir.
Why? They are what type of functions? What type of functions? Monotonically increasing functions, no? So,
Yes,
okay,
yes, sir.
that is C equal to 7, N naught, I am checking for 5, only out of curiosity. So what is this value? 7 into 5 cube minus 8 into 5 square plus 6 into 5 plus 20 less than or equal 7 into 5 cube. Is that correct? Is that correct? 7
Yes,
into 5 cube, leave it.
Yes, sir.
This is 30 plus 20. This is how much? 25 eighths. That means it is 200, no?
Yes, sir.
Is that satisfying or not?
Yes, sir. Satisfying.
So C equals 7 and N naught equals 5. Is this correct choice? C equals 7 and N naught equals 4. Is this correct choice?
Yes, sir.
Yes, both are. C equals 7, N naught equals 6.
Yes.
Is that correct choice? N naught is 4 is correct choice, means automatically N naught equals 5 also correct choice, N naught equals 7. 6 also correct choice. Anything value greater than 4, automatically it's a correct choice, no? So
Yes,
similarly, C
yes, sir.
equals 7, it is true, means whether it will be true for C equal to 8 and N naught equal 4. C equals 7 itself, if it is true, and N naught equal 4, it is true. Automatically C equal to 8 and N naught equal 4, whether it will be true or not. that value is more, no? C equal to 8, that value is more, no?
Yes,
Yes, that means automatically it is true.
yes,
But we need not do this much. Directly, simply, because if we find small constants, no, we don't get any price here, C and N naught. So that's why what is that we do is, somehow we need to find one constant, one value for C and one value for N naught. So simple way is 7 n cubed, we know that it is same as 7 n cubed, minus 8 n square is less than or equal to 8 n square plus 8 n square. Is that okay? 6n is same as 6n. Sorry, this 8 n cube. This is 6 n cube. 20 is less than or equal to 20 n cube. Is that correct? 7 n cube is same as 7 n cube. This is a highest order term. Next to 8 n square, I have taken minus 8 n square. That is less than or equal to 8 n cube. I am ensuring that every time whenever I am comparing terms, this side it is n cubed. Why? Because here highest order term is n cube. So 8 n square is less than or equal to 8 n cube. Minus 8 n square also automatically. 6 n less than or equal to 6 n cube. 20 less than or equal to 20 n cube. So now finally, what is the value you get? This right hand side is less than or equal to 7 plus 8 plus 6 plus 20. 8 plus 7 plus 8 plus 6 plus 20 into n cube. Is that correct? Is that correct? Is that correct?
Yes, sir. What
Is that
my
correct
second
or not? So what is that I am saying is, this is less than or equal to 7 plus 8 plus 6 plus 20 into n cube. Is this true or not? Easily we can say that it is true, no?
yes,
See, first term is 7 n cube. Here I have taken 7 n cube. Definitely it is not less. Second term is 8 n square. Here it is 8 n cube. Definitely it is not less. Third term is 6 n. Here it is 6 n cube. Definitely it is not less. 20 n cube. Definitely it's not less, no? So what is that I am taking? Constant coefficients, positive values I am taking. 7 plus 8, 6, 20. Then this entire value I call it as C. C, this is sum, coefficient sum. Is that correct? And n naught, what is the value that we can choose n naught? What is the value that we can choose for n naught? N naught equal, C is this much. What is the value we can choose for n naught?
greater than or equal to 4.
Definitely n naught equal to 0, it fails, no?
Yes,
N naught equal to 0 means here 20 is constant, no? All become 0, 20 less than or equal to 0. So
Not-
it is not correct. N naught equal to 1 if I take, whether it is true? N naught equal to 1. N naught equal to 1, is it true?
no,
I think it becomes true, no? N not equal to 1, it satisfies, no, madam? So C is how much? 7 plus 8, 15 plus 6, 21 plus 20, 41. So finally, what I am saying is C is 41 and N naught is 1, whether it satisfies or not. C is 41 and N naught equal to 1. Is it whether it satisfies or not? We need not even.
Sir, yes, 7 n cube minus 8 n square, no, sir.
33 minus 8 left hand side.
Automatically it satisfies, no?
Yes, sir. Yeah, it's that space, sir. Yes.
Why? Because simple logic. Here 7 n cubed is there. This is 7 n cubed. Definitely no change. Here it is 8 n square. It is 8 n cubed. Even it is more. 6 n cubed. It is more. Only for n equal 0, because this n cubed becomes 0. That's why we have problem. In all other cases, it is definitely more. No. So what is simple logic here? What is that we can take? In this case, you take positive values for all coefficients which are present here, and that sum 7 plus 8 plus 6 plus 20, that we consider it as C. And n naught you put greater than or equal to 1. Automatically it becomes true or not.
True, true,
N not equal to 1, whether it becomes true
True.
or not.
true.
Okay. Just n not equal to 1, it is true. If you are, okay, let us see one more example. Still, if we have doubt, then I will elaborate on that. Okay, let us see simple example here. Simple example. See, what is that I said is, now in 7n plus 1, we know that it is big O of n is less than or equal to some constant into n we need to show for all n greater than or equal to n naught. N naught. Okay. So for this, what I am saying is 7n, it is same as 7n. No. Why? Because this n is there, I am writing 7n. 1 is less than or equal to 1 into n, we can write. Is that correct? 1 is less than or equal to 1 into n. This is true for all.
Greater than 0.
For
n
all?
greater than 0.
N greater than or equal to, this is true for any value greater than or equal to 0. This is true for any value n greater than or equal to, n greater than or equal to. Is it true for n equal to 0? Is it true for n equal to 0?
No, sir.
No. Is it true for n equal to 1?
Yes.
Yes. Is it true for n equal to 2? Yes. For
Yes.
any value other than 0, it is true, no? Now you add both. What is this? 7n plus 1, no? It is less than or equal to 7n plus 1n. Combination will be true for, this is true for any value n greater than 0, greater than or equal to 0. This is true for greater than or equal to 1. Combination will be true for common part. Common part is n greater than or equal to 1. Is that okay? Is that okay? That means what? Easily we can say that 7n plus 1 is less than or equal to 8n for all n greater than or equal to 1. Is this correct?
Yes. Yes. Yes, sir.
We need not, because our C is 8 and n naught is 1.
One.
Some constants we need to find. Okay, no, we need not worry about whether this constant is small or large. Is that okay? Is that correct?
Yes, sir.
Is that correct?
Yes, sir.
Is that correct? Big O, it is very easy. Okay, no, big O, it is very easy. Finding constants. Is there any doubt in this?
No, sir.
Okay. Now let us see this. Let us see this. You, all of you, please read this, and if you have any doubt, you please ask me. Each step you please read. Is there any doubt? Is there any doubt? Is there any doubt in this example? 7n plus 1 is big O of n. Is there any doubt?
No doubt, sir.
Okay. Okay. This example, you please tell me. You please tell me. Oh, what is C and what is n naught? What is C and what is n naught?
For C equal to 70, it will be true for every value n greater than equal to 1.
Thank you very much, sir. So what is that I am taking is this positive absolute values I am taking all. Automatically it will be plus 3 plus 7 plus 40. And the n naught, I'll take it as 1, whether it will be true or not. whether it will be true or not. Whether it will be true or not. So what is our C? This summation 50, 50, 60, 68, 70. C is 70 and N naught is 1. Is that correct or not? Whether it satisfies the given inequality?
Yes.
It is formal definition of big O notation, whether it satisfies or not. So is there any doubt in this type of examples? Like this, any example easily we can find C and N naught. C and N naught. Infinite
Doubt,
number.
sir.
Madam?
Sir, one doubt, sir.
Please tell me. Please tell me.
For this minus 4n power 5, we can write as minus 4n power 5 is less than or equal to 0, right? Like that also we can do, no, sir?
That is also possible, because what I am saying is simply without any difficulty, easily we can find one constant. That's what I am saying.
We will get another C value, right?
See, like this, infinite number of C's are possible now.
Get another C value, but that would also be correct.
That is also correct. What you said is even it is smaller C. What you are saying, whatever you said is absolutely right. Then our C becomes, in fact, how much? 66 only.
61.
66 only.
61, sir.
Okay, like this, for each value you
3 terms
replace.
are
No?
there.
Here, this 3 we replace, then it will be how much? 3, 4,
We will get
7,
C
9.
value.
9 is 61 only. With the 61 itself, we can show. That is also correct. So that's why I'm saying no, C and N naught, infinite number of values are there. Infinite number of values are there.
And only
One
positive,
value if you give, that is sufficient.
positive constants.
Is that okay? Is there any doubt? Okay.
Positive,
So,
positive constants వరకు
so
తీసుకుంటాం.
for in general, say we are given a polynomial, whatever we discuss, no, all are a polynomial. No? If we are given a polynomial whose degree is m, then we can write it as where am is not equal to 0. It is understood that am is, even if am equals 0 also it is true. So no point in even writing that. So how to prove? Is this correct? First of all, what does it say? If we are given a polynomial whose degree is
M.
at most m. Here am we don't know. It can be even 0 also. Okay. Whose degree is at most m. If we say am is not equal to 0, then we say that degree is m. Otherwise, if am equals 0, then we don't know. It at most degree at most m. This is degree at most m. Is that correct? Now this side it is n power m. Is that true or not? First of all, is that true or not? Is that true or not? Is that true or not? That is 6n square minus 7n plus 8. Can we say that it is big O of n square? Can we
Yes.
say that it's a big O of n square? That's what it says. No, this is say a. This is a naught. This is a1. This is a2. Correct? No. Here m is 2. Is that okay? Another example, if you want. Another example. Say f of n is 6n square minus 7n plus 8 is, can we say that it is big O of n cube? Can we say that it is big O of n cube? Can we say that it is big O of n cube? We say that it is big O of n cube.
Yes, sir.
It is say actually 0 into n cubed plus 0 into n cubed. That is, here this is A3, this is A3, this is A2, this is A1, this is A0. Now m is 3. M is 3. Is that correct? Is that correct? Is that correct or not? What is its order of float? What is its order of float? What is order of growth of left side function?
Yes, sir.
N
N
cube.
square. N square.
N
N
cube.
square. Order of growth is n square. N square is big O of n cube. We know that it is correct. It is correct. That means this statement is true. Okay, this statement is true. Then how to show that this one easily? That's what we have already done. Now we are generalizing. Is it less than or equal to 6n square plus 7n plus 8? Is it less than or equal to 6n square plus 7n plus 8?
Yes, sir.
Is that true?
Yes.
Yes.
Yes,
That
sir.
means what is that I am taking? I am taking modulus for all coefficients.
Yes,
Whatever
sir.
function is given, I am saying it is less than or equal to this. Is that okay? Is that okay?
Yes. Yes.
Now, up to this step, is there any doubt? Up to this step, is there any doubt? Up to this? Okay. Now, n power I, we can write it as n power m into n power I minus m. Why? Because we know that b power l into b power m is b power l plus m. We know this now. Based on that, is it correct? Is this correct? Is that correct? Is that correct or not?
Yes, sir.
Yes. Okay. So here we have written that n power I have written it like this. Say after that, this n power m, is it independent of I? Say one more step. This is same as sigma I equal to 0 to m mod ai n power m into n power I minus m, n power I minus m. Is that okay? Is that okay? So this is equals to, sorry, this is equal. Then after this, it is same as equals to, this is equal to what? Equal to what? N power m, I can take it outside or not. It is independent of this summation I value. It is independent of I value. So we can take it outside. We can take it outside. So I have taken it outside and we return the remaining part. Now, what can you say about value of n power I minus m? We know that I varies from 0 to m. What is the value of n power I minus 1 if I varies from 0 to m? What is the maximum value of this? When I equal to m, then what is this value? N power I minus m. When I equal to m, what is n minus m? N power I minus m.
0.
So that is n
N-
power 0. I
N
equal
power
to
0 1.
this is n power
N power
0. When I equal to m 0, when I equal to 0, what is this value?
N power minus m.
N power minus m. It is 1 by n power m. 1 power m. Is that correct? That means what is the maximum value of n power I minus 1? I minus m. What is maximum value of n power I minus 1? Whether this value is less than 1 or not? Is it less 1 by n power m is less than 1 or not?
Yes, sir.
All n m everything is positive, no?
Yes, sir.
Okay. So this is 1. So that means what is maximum value of n power m?
1 only.
Maximum value of n power I minus m is 1. Is that correct?
అక్కడే వరుసగా రెండో మూడో స్టీల్ కావాలి దానిలో ఓట్స్ ఉంటుంది
I request all the participants to keep your microphone in mute. Maximum value of n power I minus m is 1. Is that correct? Is that correct? So now n power I minus m, I replace with 1. I replace with 1. Then definitely this entire top summation, it will be less than or equal to 1 into 1 into 1 means it is same as this only. Is that correct? Is that correct? Is that correct? Hence, what is that we have got finally? Therefore, f of n is less than or equal to n power m into this entire constant. What is c value here? This entire thing is c. This entire thing is c. That's what no. Whatever previous example we discussed, no, that's what we have taken. No, c value as c value as c value as c value
Modulus of quotients.
Positive values.
Sum of
sum of
Sum of
modulus
positive
of-
values.
sum of modulus of the coefficients. No,
Yes, sir. Sir, I have one doubt, sir.
hence what is it is true by the formal definition of this. Is it true or not? Big O notation. That's why we have taken that way. Okay, it is very easy for big O notation. It is very easy for big O notation. So is there any doubt up to this?
Sir, how can we say if n power I minus m equal to 1, then it will be less than of that
Brother,
expression? sir?
please. Could you please repeat?
If we keep n power I minus m equal to 1, how can we say that it is less than, sir?
Because 1 by n power, for example, if I equal to 0,
Yes, sir.
it is less than 1. No, if I equal to 1,
Okay. Yes, sir.
this is 1 minus m. No,
Hmm. Then it will be less.
I equal to 2 also. 2 minus m. No,
Yes, sir.
because maximum value I takes is m.
Oh,
Say
yes, sir.
0. This is the meaning. No,
Yes, sir.
I is between 0 and m. So
Hmm.
this value I minus m maximum I minus 1 I minus m value is between what? I minus m value is between what?
Minus m. Final one is 0.
Minus m to
0.
0.
Yes,
Is that
sir.
okay?
Yes, sir.
When it becomes negative, when it becomes that means I minus m is always negative except when I equal to m.
Yes, sir.
N power some negative value means 1 by n power that no.
Oh, oh, yes, sir.
1
Then
by
it
some
will be
positive
less.
value means it is less than 1.
Yes, sir.
Is that correct, brother?
Yes, sir.
So
Got it.
if I multiply some value with a number which is less than 1, like 0.5 or 0.6, that value gets reduced or not?
Decreased. Yes, sir.
That's why I have put less than or equal to here.
Okay, sir. Got it.
Okay,
Only
thank you.
Thank you.
So if you this big O notation, if you have any doubts, you please ask me. Otherwise, we'll move on to next example, next notation. So similarly, what is big O? Big omega. We know that n cubed is big omega of n squared. Is this true or not? Is that true or not? Is that true or not?
Yes, sir.
True, sir.
That means f of n's order of growth is more or g of n's order of growth is more in this case?
F of an order of growth is more.
F of more or equal. Okay, now that's why the same thing similar to that. Okay, now here we need to find two constants c and n are such that f of n is greater than or equal c into g of n. C into g of n. So now if we similar to that, if we draw diagram for f of n and c into g of n, which one will be top? F of n value is more or c into g of n is more?
F of n.
That's why it is above c into g of n, no? It is above c into g of n. Is that correct? Curve for f of n is above c into g of n. Why? F of n numerical value is more than numerical value of c into g of n. Is that okay? Is there any doubt? Is there any doubt at this?
No, sir.
Okay.
No, sir.
Okay, some simple example will take. Show that n into n plus 1 by 2 is big omega of n square. Is that true or not, first of all? Is that true or not? Is that true or not? N into n plus 1 by 2 is big omega of n square. Is that true or
Yes.
not?
True, sir.
Okay. Now what is f of n here? F of n is 1 by 2 into n square plus 1 by 2 into n, and g of n is n square. Is that okay? Now f of n 1 by 2 into n square plus 1 by 2 into n should be less than or equal some constant into g of n. Sorry, this is
Greater than or equal to.
greater than or equal to, for all n here n greater than or equal this. Okay, n greater than or equal this. Now you tell me what are the constants that we need to take. If all terms are positive, is it easy or not? Easily we should be able to give answer now in this case. Easily we can say that 1 by 2 into n square, 1 by 2 into n, it is greater than or equal simply first term. Is that correct? N
Yes,
is
sir.
non-negative. No, n is non-negative. That's why is
Yes,
this
sir.
true?
Yes, sir.
Yes. Yes, true, sir.
Okay. Now, can we put it as n greater than or equal to 1?
No, sir. If it is 0 also, it will be satisfied. No, sir.
If it is satisfying for 0, it will automatically satisfy for 1 also, no, brother?
Oh, yes, sir. Sorry.
Because see, our intention should not be any small constant and all. Okay, no, it doesn't matter, no, whatever it may be.
Okay, sir.
First of all, this analysis itself is for n tends to infinite. Okay. Okay, brother. Is this correct?
Yes, sir.
Okay, it's always true. No, it's always true. Now that means what is C here? 1 by 2 and n naught is 1. Even C equal to 1 by 2 and n naught is equal to 0. Is this correct or not? Is that correct or not?
Correct.
Is that correct or not?
Yes, sir.
That also it is correct. It is 1 by 2 and n naught is equal to 2. Is that correct or not? If it is true for 0, automatically it will be true for 1, automatically it is automatic. If it is true for 1 by 2, 1, whether it will be true for C equal to 10 and n naught is 1. If it is true for 1 by 2, whether it will be true for C equal to 10 and n naught equal to 1.
Yes, sir.
No, no. Why? Because if it was less than or equal to, no, then it is okay. But here what happens? 1 by 2 into n square plus 1 by 2 into n. If I take this is wrong. 1 by 2 into n square plus 1 by 2 into n, whether it is greater than or equal to 10 n square. Is that greater than or equal to 10 into n square? Is that greater than or equal to 10 into n square?
N is equals to 1.
Yes.
No, sir.
That's not correct, no?
Yes, sir.
But for in case of big one, no, that was less than or equal to, that's why we were able to write it this way. But here it's not. But if it is true for C equal to 1 by 2, whether it will be true for C equal to 1 by 4? Is it true for this? C is lower side. C is lower side. C is lower side. Whether it will be true?
Sir.
Is it true or not?
This will be true, sir.
It's a true. So that means any value of C which is smaller than 1 by 2, whether it will be true or not. Any value of C which is smaller than 1 by 2, whether it becomes true or not. Any value of C which is smaller than n by 2 or 1 by 2. Automatically it is true, no? Automatically it is true. So even here also it is very easy. If all terms are positive, for example, 7nk plus 8n square plus 20n plus 40. Can we say that it is greater than or equal to 7 into n cube for any value of n greater than or equal to 0? Is this true?
Yes, sir.
That means in this case, if that means 7n square plus 8n square plus 20n plus 40 is big omega of n cubed is correct or not? This is true, no? Here what is C value? C equal to 7, n naught is 0. That means what I'm similar to big O where we have taken summation when all terms are whether they're positive or negative. But here if all terms are positive, simply the highest order term, that coefficient you take as C, that is sufficient. Provided all terms are positive. All terms are positive. Is that okay? Is that correct? Is that correct or not?
Correct.
Okay. So these are some general methods. But the problem comes when there are negative terms. It is very difficult. It's very difficult. We will see with a simple example why it is. Simple example. Let us take. Show that n into n minus 1 by 2 is big omega of n square. So please all of you give it a try. Okay, now all of you give it a try for 1 or 2 minutes. So any answers? The same example for big O, we were able to do it in no time. We were able to do it in no time. Even if the all terms are positive, that also we can do it in no time. whether this inequality is true 1 by 2 into n less than or equal to 1 by 4 into n square, whether it becomes true. Whether it becomes true for n equal to 0, whether it becomes true this inequality. N equal 0, is it true? When there are no constant coefficient terms which are independent of n equal 0 automatically true. So based on that we should not go. When n equal to 1, if we take, is that true? N equal to 1, is it true? N equal 0, it will be confusing. Why? Because when there are no, it is only function of n, with n being part of every term, then automatically 0. No, both values become 0. If there are no constants which are independent of n. Okay, so n equal 0. N equal to 1, if we check, is this true?
No.
1 by 2 into n less than or equal to 1 by 4 into n. Is that true?
No.
No. N equal to 2.
Yeah, it is true then.
N equal to 2. 1 by 2 into 2. This is true. Okay, this is 2 square. This is true. This is true. So now here, so here my intention is to tell you that it is, if some terms are negative, in case of big omega, it is very somewhat difficult to find out constants, whether you experience that or not. If it was big O, easily would have given constants, no, what are C and N naught in no time. Are you okay? Now let us try to answer this. 1 by 2 into n square, is it same as 1 by 2 into n square? This is true for any value n greater than or equal to 0. Now 1 by 2 into n, is it less than or equal to 1 by 4 into n square? Is it true? 1 by 2 into n less than or equal to 1 by 4 into n square. 1 by 4 into n square, I can write it as 1 by 2 into 1 by 2 into.
No, sir.
It is true, no? So 1 by 2 into n less than or equal to 1 by 2 into this. That means what is n value here? What is n value? Yeah, if it is true, what is n value? N will be definitely greater than or equal to 2. Is that correct? How this thing gets cancelled? One is, that means 1 is less than or equal to 1 by 2 into n. That means n is 2 is less than or equal to n. That means what? N is greater than or equal to 2. Is that correct? Is that correct? That means this is true for all n greater than or equal to 2. Is that correct? Is that correct? Is that correct or not? So now you combine this, you subtract from 1, this is say 1, this is 2. 1 minus 2, if we do, what is that we get? Same thing we get or not? Same thing we get or not? So what is this other side? What is that we get a right hand side? Right hand side, 1 by 2 into n square minus 1 by 4 into n square. What is this? 1 by 2 into n square minus 1 by 4 into n square. It is same as 1 by 4 into n square. Is that correct? Is that correct? Is that correct or not? Is this correct or not? Is there any doubt still? This is 1 by 4 if I take, is that correct or not?
For what value of n?
Sir.
That is, this is true for n greater than or equal 0. This is true for n greater than or equal 2. Combination will be true for? Combination will be true for?
Greater than or equals to 2.
Greater than or equal to 2. So that means finally what are the values that you have got? C equal to 1 by 4 and n not equal to 2. Is this correct? Is that correct or not?
Then it is correct.
Because no, if there are negative terms, it is bit difficult. Okay, it's a bit difficult to actually find proper constant C and n naught. C and n naught. We need to do some more calculations. Okay, C and n naught. Is that okay? So this thing, no procedure is this. You practice more examples, but still without even knowing formal definitions of asymptotic notations, we can actually solve any problem related to these asymptotic notations. Because in competitive exams they don't ask for proof. Okay, but in regular examinations or regular, to understand it better, we should know what are formal definitions of asymptotic notations. Even if you have not understood any formal definition of big O and big omega, still all problems you will be able to solve without any difficulty. Okay, but if you understand it, you will be able to write proper proofs also. Is that okay? Okay. Now quickly we complete other notations, remaining 3 notations. Now 7n square minus 6n minus 56. It is big omega of n square. Is that correct? Is that correct?
Yes.
7n square minus 6n minus 56 is big omega of n square. Is that true?
Yes. Sir.
Yes,
Yes,
it is
sir.
true. Only difficulty is we need to find what are proper constants here. What are proper constants here? Okay. Here we tried with say c equal to 1, c equal to 1, c equal to 1, c equal to 1. And n not equal to 0, say n not equal to 0. Is that true? Is that true? N not equal to 0. 7n square minus 6n minus 56 greater than or equal to 1 into n square. Is that true? Is that true?
No.
No. Why? Because 0 here minus 56 we get. This side it is 0. Minus 56 is not greater than 0, no? Okay. So this fails. Instead of this n equal to, this is n. This is not correct. Say c equal to 1 and n naught is 1. Is this true? Is that true? Is that true? N equal to 1, if we take, what happens? 7 minus 6 minus 56 greater than or equal to 1 into 1
No.
square. It fails, no? Why this problem has occurred? Same thing we observed in case of big O also. When there is a constant which is independent of n, it is bit difficult. Okay, no? That means n equal to 0, 1. We need to cleverly choose this n naught so that this impact is gone. Okay? So that's why n equal to 5, if n equal to 4, if we try, n equal to 4, n equal to 4, is that true? Is that true? Still it is not true. Now you check for n equal 5. N equal 5. You check for n equal 5.
True, sir.
That is true. No, that's why C equal to 1 and n naught is 5. It satisfies. It satisfies. Like that, there are different constants we can find. Okay. There are different constants we can find. This is also true. This is also true. Hence, this is true. So only one value we give for C and one value for n naught. That is sufficient. That is sufficient. Sufficient. Okay. If you really want to understand it completely, you please do it for this example. Okay, no? Log n factorial is so that okay. So I'll send you the solution also. You please try to go through that and understand. Log n factorial is big omega of n log n. Is that true or not? Is that true or not? Log n factorial is big omega of n. What is order of growth of log n factorial?
N log n.
N log n.
Log.
Is this true? Both are true. Because these are very lengthy. Okay, you will get 1 page or more than that. You please try it and try to understand. Then you will get complete clarity on how to do it. Complete clarity on how to do it. You go through that. Still, if you have any difficult, then after some later we can even discuss in class if you want. Okay. First, you go through that. Next one. Next notation. Theta. Theta means what? Order of growth of f of n is same as order of growth of.
Sir, can you go to backslide, sir, once?
Order of growth of f of n is same as order of growth of g of n.
Hello? Hello, sir.
Hello.
Sir, can you shift to backslide, sir, once?
Please tell me.
I just want to take a screenshot, sir. That's it. Thank you, sir.
This anyhow, I first 2 classes I have already said. I hope you must have received this lecture notes for first PPT for first 2 classes.
Okay,
Okay.
sir.
This also I'll share immediately, maybe tomorrow morning. Okay.
Thank you, sir.
Okay. You spend time on understanding it. I will send it definitely. Okay. So f of n is theta of g of n. That implies order of growth of f of n is same as order of growth of g of n. Now, how to show that order of growth of f of n is same as order of growth of g of n? Or let me put in another way. How to show that a equal to b? How to show that a equal to b? One way of showing a equal to b is a is less than or equal to b. We can show. Okay. We can show a is greater than or equal to b. From these two, what is that we can conclude? In order to show that a equal to b, one way of doing is first we show a is less than or equal to b. Next, we can show a is greater than or equal to b. From the two, can we conclude that a equal to b? Is it follows? Is it follows? A is less than or equal to b is true. A is greater than or equal to b is also true. Means what should be the relation between a and b? What should be the relation between a and b? What should be the relation between a and b? A is less than or equal to b is true. A is greater than or equal to b is also true. That means what? That means what? A should be equal to b, no? Yes, similarly, in order to show that both have same order of growth of f of n is same as order of growth of g of n. First, I'll show that order of growth of this is a, this is a, this is b. You can consider. First, I show that order of growth of f of n is less than or equal to order of growth of g of n. Next, I show that order of growth of f of n is greater than or equal to order of growth of g of n. From these two, can you conclude that both have same order of growth? Both have same order of growth?
Yes.
That no. First one less than or equal to second one. Second one again. First one greater than or equal to second one. That means what? First one should be same as second one. No. Okay. Now, order of growth of f of n is less than or equal to order of growth of g of n. What does it mean? What does it mean? It means that f of n is big O of g of n. No. That is the meaning of that. No. That's what we learned. No. Order of growth of f of n is less than or equal to order of growth of g of n means we can write it as f of n is big O of g of n. Is that correct?
Yes.
Order of growth of f of n is greater than or equal to order of growth of g of n. That means what? That means what?
Big omega of
F of n is big omega of g of n. F of n is big omega of g of n. Is that okay? Is that okay? Okay.
Yes, sir.
Now, if f of n is big O of g of n, then by the formal definition of big O, what exists? There exists two constants, say C and okay, this I call it as say C2 and N2. Okay, anything I can take now, C2 and N2, such that f of n is less than or equal to C2 into g of n for all n greater than or equal to n2. That is the meaning, no? Is that correct? Is that correct? Is that correct? See, f of n is big O of g of n means, what does it mean? According to formal definition, there must exist two constants, C2 and N2, such that f of n is less than or equal C2 into g of n for all n greater than or equal to N2. Is that correct? Okay.
Yes.
Similarly, if f of n is big omega of g of n, then what is that? It's according to the formal definition, what should exist? Formal
F of
definition
n
of
is-
big omega. Formal definition of big omega. What should exist?
F of n is greater than or equal to
There is formal definition. There exist two constants. Say C1. We can call it as C1 and N1. Okay, C1 and N1, such that f of n is greater than or equal to C1 into g of n
for all n
for
greater
all
than or
n
equal
greater
to
than or equal to N1. This I call it as 2. So in one inequality 1 and 2, f of n is common, no? Inequality 1 and 2, f of n is common or not?
yes,
F of n is common or not?
yes,
So combiningly, what is that we can write? Combining both
F
this
of
equation, inequality 1 and 2, what is that we can write? We can write
g of n is
f of n. Let us take one way. This is less than or equal
to
C2 into g of n, and the same f of n is greater than or equal C1 into g of n. Is that correct? This is true for n greater than or equal to n2. This is true for n greater than or equal to 1. Combination will be true for some constant n greater than or equal, let us say n0. Is that correct?
Yes, sir.
Is that correct?
Yes.
We can even take this as maximum of n1 comma n2, whether it will be true or not. Maximum of n1 comma n2.
Sure, it is minimum of n1 comma n2, I think. Maximum.
If it is true for minimum, automatically it will be true for maximum, no, madam. If it is true for minimum, automatically it will be true for maximum also, no?
Sir, but we have to consider minimum or maximum. I'm getting the question.
It doesn't matter whatever we consider. One constant we need to give. One
Okay, sir.
constant we need to give. But actually, we need to consider common part, which is maximum. That's what we have already discussed now. If a function, we have two inequalities. One is true for this value onwards. This is say 20. Another is true from 24 onwards. Common part will be true for 24 onwards, no? 24 onwards, no?
Yes, sir.
Correct, no?
Yes, sir. Yes.
Okay, this n naught I call it as maximum of
N1 comma N2.
is that correct? Is that correct? So that's what is the definition. That means here how many constants we need to find? How many constants we need to find?
Two constants.
That is 3 constants. This is C1,
C1, C2,
C2 and n naught. Which is nothing but what is that in this inequality? What is that we are showing? We are showing that f of n's order of growth is less than or equal to order of growth of g of n. Next, we are showing that f of n's order of growth is greater than or equal to g of n. That means this inequality says that order of growth of f of n is same as order of growth of g of n, which is nothing but the formal definition of big theta notation. Is that's what now is given? See, theta notation means what? Both have same order of growth. How to show that both have same order of growth? First, we say that f of n's order of growth is less than or equal to order of growth of g of n. That is nothing but big O. Okay, big O. F of n is big O of g of n. Next, we show that f of n's order of growth is greater than or equal to g of n's order of growth. That is nothing but f of n is big omega of g of n. We write formal definitions for big O part as well as formal definition for big omega part. By combining that, we'll get again an inequality for exact order of growth of f of n and g of n, which is nothing but the definition of theta. Unlike big O and big omega, here how many constants do we need to find? 3. There are 2, but here it is 3. Here it is 3. Now, out of these 3, which part has a highest value, numerical value out of these 3? Which one has highest value?
C2.
C2 into g of n, no? That's why it is
Yes, sir.
top. It is in top. This is highest, no?
Yes, sir.
So which has smallest value? Which has
C1 into GM.
C1, this is lowest, no? Is that okay? Is that correct? F of n is middle. For values below n naught, whether it matters which is more, which is less, here it doesn't matter, no? One may be more, the other one may be less, the other one may be more, the first one may be less, all those things. So it actually doesn't matter to us. Below n naught, we don't know which is more, which is less. Does not matter. Does not matter. Below n naught. Is that okay? Is that okay? So that means from this point onwards, we know the relation. Okay. Okay, simple example. N into n plus 1 by 2 is theta of n square. So that
Cheppu.
n into n plus 1 by 2 is theta of n square. How to prove this? How to prove this? What is f of n? We have already done into that for big O also, big omega also. This is f of n. G of n is n square. G of n is n square. Now, according to the definition, what is that we need to find? 1 by 2 into n square plus 1 by 2 into n less than or equal to some constant into n square, and the same value should be greater than or equal to some constant into n square for all n greater than or equal to some constant. These three constants we need to find. Can you tell me, already we have solved this problem, no? For big O also, big omega also. Tell me the constants. What are three constants? What are three constants? One by 2 into n square plus 1 by 2 into n, it is less than or equal to, less than or equal to, you look at the right part.
2 is 1.
Sir, less than or equal to? Here, what
C2
is
is
that we
1.
can do?
I'm just telling one constant. C2 is 1.
Okay, C2 is 1. Okay, C2 is 1. Okay. Next. What about C1? What about C1?
By 4.
C1?
C1 is 0.5.
C1 is 1 by 2.
Yeah, 0.5, 0.5.
Point. See, because now look at this part only. Here all terms are positive. It is like a big O only, no? It is like big O. So that means what is the constant we can take here? Whatever coefficients are there, this n terms, okay, no. That coefficients sum we take, positive sum. Okay, no, absolute value sum. 1 by 2 plus 1 by 2, 1 we take. Automatically this condition is satisfied or not? Automatically that condition is satisfied or not? That's what we discussed, no, for big O.
Yes, sir.
Okay. Similarly here for big omega. Now the other left side, this part, okay, red color part, if we constant, if we look at this part, here 1 by 2
No notation.
into n square plus 1 by 2 into n is there. This should be definitely greater than 1 by 2 into n square. Is that correct? It should be greater than 1 by 2 into n square, no? Why? Because here 1 by 2 into n square plus some additional quantity is there, no? Plus some additional quantity is there. Okay. Hence, is that true or not? That's what we discussed now for big O, big omega. For the highest terms, only coefficient we take, that is sufficient if all are positive. That's why 1 by 2, if we take, that is over. What I am saying is 1 by 2 into n square is less than or equal to 1 by 2 into n square plus 1 by 2 into n. Is that correct or not? Is that
Yes,
correct or
sir.
not?
Yes, sir.
Now the combination will be true for, whether it will be true for
Big
any value of
connotation.
1 or more than 1.
Yes, sir.
N equal to 1, is it true?
Yes, sir.
N equal to 2. N equal to 2.
Yes, sir.
Yes, N equal to 3, it is true. So that means N greater than or equal to 1, it is true. So therefore, what are our constants? What are our constants?
1 by 2, 1.
C1 is 1 by 2. C2 is
C2 is 1.
1 and N naught is also 1.
Greater than. Okay, sir.
N naught.
Then
Okay. Are there? Can you give any other constants based on this? Once you know that these are the values, you simply give me some other combination for C's and N naught based on this answer. C1. If I take 1 by 4, whether it
1 by
becomes wrong.
4. Yes, sir.
C2, if I take 20,
2.
it becomes wrong.
No, sir.
Anything more than this, it will do, no.
Yes, sir.
And N naught, anything
2.
5. Okay, thank you, brother. Okay, 2 only. Is that correct? This is once one value for each of the constants, automatically we can give many values based on that. Infinite number of options will be there. Okay. So this is the way of doing. This is only to prove that. Otherwise, simply most of the cases, no, we can even see that if it is a polynomial related thing, directly we can give answer. No, we need not even do this entire exercise. We need not do this entire exercise. Okay. So similarly, if it is n into n minus 1 by 2, can you tell me n into n minus 1 by 2? What are the values of C1, C2, and n naught? N into n minus 1 by 2 is theta of n square. Another example show that n into n minus 1 by 2 is theta of n square. Any answers? No. Any answers? Okay, 0.5.
1 by 2.
Okay, let us. So what are so that n into n minus 1 by 2 is theta of n square. So f of n is 1 by 2 into n square minus 1 by 2 into n, and g of n is n square. So according to that formal definition, we need to write this is f of n. It should be less than or equal some constant into n square for all n greater than or equal some constant, and it should be greater than or equal to also some constant into g of n. So what? Okay, someone has sent something in chat box. What are answers? Any answer? 0.
Sir, C1 is n by 1 by 2.
C1 is 1 by 2, madam. This is not correct, madam. Why? Because here itself easily we can say no. This is 1 by 2 means 1 by 2.
Sir, can we take 1, sir, or C1?
1 by 4.
This is not correct, no, madam.
1 by 2 n square less than or equal. Yes, sir. Yes, not correct.
Can we take C1 is equal to 1?
C1 equal to?
1.
No, it's 1 by
1 by
4.
2 itself, it is wrong, means 1 automatically it is left wrong, no brother.
So it is 1 by 4, sir.
1 by 4 it works.
Yes.
Because see, 1 into n square is less than or equal to 1 by 2 into n square minus 1 by 2 into n. Is this correct? No, 1 into n square we can write it as 1 by 2 into n square plus 1 by 2 into n square. No, is it less than or equal to 1 by 2 into n square minus 1 by 2 into n? No. Why? Because this is positive, this is negative. This first quantity is same. Correct? No? That means C1 is 1 is also wrong. C1 is 1 by 2 is also wrong. Another option is C1 is say 1 by 4. This we have already done, no, same thing. But this example we solved, no, already. 1 by with the same
Yes,
1
sir.
by 4 only. 1 by 4 into n square less than or equal to 1 by 2 into n square minus 1 by 2 into n. This we have already, that's why I asked you to do. Big omega, this case, this example we have done now. Is this correct or not? Is this correct or not?
1 by n equal to 1. 1 by 4. Is equal to 1 by 4.
N equal to 1, it is not correct.
Yes, sir. Yes, sir.
N equal to 2. N greater than or equal to 2, it works. This is one side. What is the other side? Other side, 1 by 2 into n square. That means C equal to 1 by 4 we have got. 1 by 2 into n square minus 1 by 2 into n. It should be less than or equal something into n square. This is very easy, no? Tell me what is value of C2? What is
1.
value of C2?
C2 is 1.
1 by 2.
Simply even 1 by 2 will do, no? Because we are subtracting
that will
something
also
from
work,
1
yeah.
by 2. 1 by 2 into n square, because both are same. Here we are subtracting, so automatically it is true. But it will be true for all n greater than or equal to 0. Is that okay? So this is say 1, this is 2. If we combine 1 and 2, what is that we get? 1 by 2 into n square minus 1 by 2 into n. It is less than or equal to 1 by 2 into n square, which is greater than or equal to 1 by 4 into n square. For all, maximum of these two, this is the 2, this is 0. Maximum of these two, 2. Is this correct? So therefore, is that okay? Is there any doubt?
Sir, 1 minute, sir.
Please tell me, madam.
1 by n square. Okay. Here common part is this one. Okay, sir.
Shall I move to next?
1 minute, sir. For all is greater than or equal to 2 n square. Okay, sir.
Okay, thank you. You please see this. Is that-
Here, like a trial and error method, sir. These are big omega and big theta.
Because both functions we need to combine, we need to compare, madam, somehow based on that, because it is
Big O is somewhat little bit easy.
Why it is very easy.
Uh-huh.
Very easy, not little, very dead easy.
Uh-huh. Yes.
Big omega also it is very easy if there are negative terms. And if all terms are positive, it is very easy. In big omega, if all terms are positive, it is very easy. What I am saying, I don't know. That is, if 70 into n cube plus 8 into n square plus 9 into n plus 20 is big omega of n cube. Here easily we can give constants, no madam. So that this. So what are the constants that we can give, madam, in this case?
Constants are?
It should be greater than or equal to something into n cube, no?
Yes, sir.
For all n greater than or equal, within a second we should give answers. What is C and n?
70 n cube.
Thank you very much, madam. C equal to 70 if I take, this entire value will be automatically greater than or equal to 70 into n cube, no? And what is n naught? Any value you take, even if I take a 0 also, it will be true, no?
Yes, sir.
Some are very easy. Okay, in big omega, if all terms are positive, it is dead easy. 1 second we can find.
All terms are positive.
All terms of that means what I'm
Hmm.
saying is, if f of n is something like this, am n power m plus am minus 1 n power m minus 1 plus n is 1 plus a1 into n plus a naught, then here for all 0 I 0 less than or equal to I less than or equal to m, ai is greater than or equal to 0. That means all are positive. All are positive. All coefficients are positive. Then what is that we can say? F of n is greater than or equal to am into n power m. It is straightforward, no? Only first term we are taking and greater than or equal to am into n power m we are writing.
Yes.
Because other term all are we are adding all. Only first term we are taking. So that means what is C value? Same as am. What is n naught? It will be true for any value of 0. Greater than or equal to 0.
Yes.
No?
Yes.
So if you have any doubt up to these 3 notations, you please ask me. Otherwise, I stop here. Then after.
Sir, here one doubt in yesterday's class, sir.
1 second.